All right, everyone. We are going to be going over our very first homework um, in terms of a video. So here it is. We're going over exponential growth and decay word problems. And I'm going to go over all of these. So if at any time you need to pause it or rewind it or go over it again, or heck, just get through some of these problems that you already went over, just fast forward through it. All right. So starting with number one, find the bank account. Find a bank account balance if the account starts with $100 and has an annual rate of 4%, and the money left in the account is for 12 years. All right. So we're gonna go ahead and use our formula that we learned in class today, which is the compounded by n times per year. And in this case, it's gonna be an annual rate. So that means that's one time 4% per year. All right. So that's going to be the compounded n times per year. So the equation is going to start off with A equals 100 parentheses 1 plus the 4% is going to be translated to 0.04. And that's going to be once each year. So it's going to be the n is going to be 1. And again, the n is going to be 1, and that's going to be multiplied by 12 for 12 years. Okay. And in the calculator, you're going to go ahead and type it in. And you can use mine or yours, or you can do it in smaller steps, but I'm going to go ahead and do it all at once. It's going to be 100 parentheses 1 plus, and I'm going to be doing this 0.04 divided by 1 in my head, which comes out to be 0.04. And then that's going to be, and I'm going to do 1 times 12 in my head, or you can do it in the calculator, but I'm going to go ahead and just write down 12. And that's going to come out to be $160.10. Right? So that comes out to be grand total of $160.10. Right? And that kind of makes sense. After 12 years, 4% interest is not a lot, and they're only going to be compounding this once a year. So after 12 years, you make about $60. Right? You didn't put in much, you're not going to get much after 12 years. All right. So moving on, number two, 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? Right. So a couple things you can do. You can figure out, okay, between 1994 and 1985, how many how many years has passed, right? So you could do a little bit of a subtraction there, and you come out to be 9 years, right? So you're going to go ahead and start with your formula, the formula that we learned in class, which is A equals, okay, and our principal is going to be 285, meaning that's how many that we start out with, times 1 plus, and the interest rate or the percent is going to be 75%, which translates down to 0.75. And that's going to be over, and then this is going to be 0.75 per year. So that means it's once a year only. Okay, so that's n times a year. That's once per year, and that's once a year, and that's going to be over 9 years, like I mentioned earlier. Again, in your calculator, you're going to go ahead and type in 285 parentheses, and again, these ones times 1 and divided by 1, they're not going to matter much. So I'm just going to go ahead and put in 1.75, because that's what this part comes out to be. 1 plus 0.75. So I'm typing in 1.75 to the power of, and then 1 times 9 is just 9. And that comes out to be 43,871. Excuse me. So that comes out to be 43,871.98637. But since we're talking about people or cell phone subscribers, we're going to go ahead and approximate that to be about 43,872 subscriber. Okay, I'll just put subs. Okay, so that was number two. Number three, bacteria can multiply at an alarming rate, at which each bacteria splits into 2 new cells. Okay, so 1 bacteria becomes 2 bacteria. So it basically makes a clone of itself. That's thus doubling. Okay, so that's what it says. If we start with only 1 bacteria, which can double every hour, how many bacteria will we have by the end of 1 day or 24 hours. Since we're talking about hours, it's a little tricky because we're talking about hours the whole time, and then at the end it says at the end of 1 day. So you got to be careful. Don't use one. Use 24 hours. Right. So we're gonna go ahead and again and start with our compound um, equation. Right. So which is A equals, right. That's our final amount, and that's what we're looking for. But we do start with 1 bacteria, right? And then we're going to go ahead and write in the rest of our formula. It's going to be 1 to keep that 1 there, the original amount, and the plus, and this is going to be, since it doubles, right? That means that the percent is 100%, right? It actually creates a duplicate of itself. So it's going to be 100% or just 1. And it's going to do that n times or once every hour. So that the n is 1, and that's 1 as well. And then that's for 24 hours. So 1 times 24. Okay, again, that 1 on top, that's going to be 100%. But 100%, if you use a decimal and you move that decimal 2 places back, you get 1. Okay, that's why up here, 75%, we move the decimal back 2 places, we get 0.75. Okay, 100%, you move the decimal back 2 places, you get 1.00, or just a plain old 1. Okay, so hopefully that did not confuse you too much. Okay, again, in my calculator, I'm just going to go ahead and type in 1 parentheses, and again, all of this I'm going to do by hand. 1 plus 1 over 1. Okay, 1 over 1 is just 1, and 1 plus 1 is just 2. So in my calculator, I'm going to type in 2 to the power of 24. Okay, and that's going to equal that much. So that's going to be 16777 216, and this is going to be bacteria. Okay. On the side note, you could have actually done this without using this formula. Okay. If you look on the side toward my calculator, so 1 bacteria, if you double that, that means it times it by 2. So after 1 hour, you get 2 bacteria, right? Makes sense. And 2 bacteria, if they each double, so 2. So if I times that by 2, so after 2 hours, you get 4 bacteria. And since I got this going, I can keep getting into it. So 4. So that's after 2 hours already. Okay. So that's 3 hours. 4 hours, 5 hours, 6 hours, 7 hours, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 hours. And you can see it's the same exact number that we get there. 16, 7, 7, 7, 21. Oh, actually, that's pretty close. 16, 7, 7, 7, 2, 1. Oh, sorry, that is exactly the same. There it is. That was my mistake. 16, 7, 7, 7, 2, 1, 6. And it's exactly the same thing. Okay. Okay, that was fun. All right, number 4. Each year, a local country club sponsors a tennis tournament. Play starts at 128 participants. During each round, half of the players are eliminated. How many players remain after 5 hours? All right, so this one is going to be based off of the half-life, and this is exactly a half-life equation. Okay, because half of the players eliminate. So after every round, half the players eliminate. So our equation or formula is going to be A equals, okay, starts with 128. That's our principal, right? We're going to lose half of it. You can write half, or you can write 50.50. I'm going to go ahead and write half down, right? And that's going to happen for 5 rounds, and each round. So after every round, so that's the total time. The total time is going to be 5 rounds, and then n, the number that's going to happen at is at once after every round. So the n is going to be 1, right? So if essentially you can just write down to the 5th power. Okay. Okay, and in your calculator, you can type in 128 parentheses 1/2 or 0.5 is fine, to the power of 5, and that gets you down to 4 players after 5 rounds. Okay, and again, this is something you could do on the calculator, and it's comprehensible enough to where you can actually make sense of it. Okay, think about it: 128 players, right? And there's half of the, and so basically half the players get eliminated. So you divide it by 2. Okay, or you could say multiply by 1/2. So 128 divided by 2. So after one round, you get 64 players. Okay, and then after the second round, so divided by 2 again, after the second round, you get 32 players. And since I have this function going on in my calculator, after I do it 2 times, so after 2 rounds, there's 32 players. If I just hit enter, so 3 rounds, 4 rounds, 5 rounds, and you see it comes out to be 4 players just the same. Okay, so you could have done this without knowing any formulas. Okay, so 5. The population of Winnemucca, Nevada can be modeled by this function right here, where T is the number of years since 1990. What is the population in 1990? So this actually isn't a problem where it's asking you to do anything. It's just asking you, hey, do you know what's going on? So in 1990, this is your initial population or the principal. So you want to say the population in 1990 was 6191. I believe that's the, yep, okay. And that's people. Okay. Part 2, or second part, by what percent did the population increase by each year, right? And again, it's just asking you to know what or how to identify certain parts of a formula. So inside here, remember, inside this part, it should be 1 plus the rate over the time, or the number of, the number of times it gets compounded. In this case, it's going to be 1 time, because um, it says T is the number of years each year, right? So it's talking about each year. So that means that it's once a year. So that's R over the N, and we know that the N is going to be 1. So in this case, it's 1 plus what, right? Would make 1.04. So that way we know by looking at that, it's going to have to be 1 plus 0.04. So that means that our percent is based off of this 0.04, or we can call this 4%, because 0.04, 2 decimal places backwards, makes 4%. So we want to say that the population increased by 4%. Okay, and that's pretty much it for the number 5. Okay, number 6, you have inherited the land. Sorry, let me start over. You have inherited land that was purchased for $30,000 in 1960. Believable. The value of the land increased approximately 5% per year. Also believable. What's the approximation value of the land in the year 2011? Okay, this is a good question, because if you're looking into buying homes, or your parents, or this is actually a good question for you. So 30,000 back in 1960, that was a lot of money. But let's see how much money that is going to be. How much money will we make if we had invested 30,000 back in 1960 on land? Okay. All right. So we're going to go ahead and start with our formula. A equals, and this is going to be our initial amount. It's going to be 30,000. Okay, and then we're going to have the 1 plus, and then it's going to increase by 5% per year. So that's the rate, and that's the number of times per year, and it's also 1 and 1. Oops, sorry, I was trying to erase these little dots, kind of bugging me, right? So it's going to be, the rate is going to be 0.05 or 5%, and it's going to happen once a year, and that's going to be 1, because that's the number of times per year. And then you have to figure out, okay, 1960 all the way to 2011. So you have to do some subtraction. So 2011 minus 1960. So how many years is that? Okay, that's 51 years, and that's what you're going to have to use as a time. So it's 1 times 51. Okay. And again, a couple things you can do in the calculator. You don't need to worry about the 0.05 divided by 1. That's just 0.05. And again, you don't also have to worry about the 1 times 51, because that's just 51. Okay. So that's going to get you a total of, and you have to do that on the calculator. So if you want to figure out for yourself, pause this video and then crank it out on the calculator, or you can watch what happens. So 30,000 parentheses 1.05. I'm just adding it all together. Okay, I'm just adding this all together in my head. So 1 plus 1.05, that's like $1 plus 5 cents, or you can call it $1 and a nickel, right? So 1.05 raised to the power of 51. Okay, and you're going to get a grand total of 300. And this is money, so we're going to go ahead and use the decimals as well. 361,223.09. And that actually does make sense for nowadays real estate and land and home prices. Okay. Number 7, during normal breathing, about 12% of the air in the lungs is replaced after one breath. Okay. So the number of times this happens is once after every breath. Okay. Write an exponential decay model for the amount of original air left in the lungs if the initial amount of air in the lungs is 500 milliliters. Okay. So that model is going to go something like this. So we're going to use that exponential decay model, but we're not going to use that half-life. Okay. It's a decay model, but it's not going to be the half-life. So it's not going to be 1/2. Right. So we can talk about it. So A equals our original amount, 500 milliliter. Okay. How much do we have left? Well, if we lose 12% of the air, okay, then that means that we will have only 0.88, or 100% minus 12% leaves us with 88%, which in terms of decimal comes out to be 0.88. Okay. And that's going to, and then we want to know, let's see, and how much of the original air is present after 240 breaths. So that's going to be, how many times is that? That's 240 is the amount of time, and that's going to be divided by 1, or after every 1 breath. And again, that's not going to affect our equation at all, so we can just get rid of that division by 1. Right? So you just got to put it into the calculator just like that. 500 parentheses 0.88, and then to the power of 240. And that gets you that number, which, if you don't know what that number means, it's a very small number. Okay. That number means this right here, 2.37 and yada yada yada, bunch of other. And then you have the decimal right here, right? And that decimal needs to move back. You see it says E negative 11. That means that's a scientific notation for times 10 to the negative 11th power. Meaning you're going to move that decimal place 11 places to the left. So if I'm following this, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's where the decimal place needs to move to. So that decimal right there, oops, wrong one. That decimal right there needs to move all the way right here, right there. And guess what? You're going to have that many zeros in front of that 2. So it's going to be 0.0000000000237, and then some change. And that is going to be your number. And if you think about it, that does make sense, right? If you take in 1 breath and then you let it out, okay, most of it comes out. Only 12%. 12% is going to be replaced, right? You took in all that oxygen and all that, whatever that's in the air. But by breathing in and breathing out, okay, eventually, after 240 breaths, eventually, okay, most of that's going to come out, okay? If not all of it. I mean, this is just a very small amount left in your body, okay? So that's, and that's going to be in milliliters, okay? Very small amount. Okay, backside. Right, number 8. An adult takes 400 milliliters of ibuprofen. That's like Advil, right? Each hour. The amount of ibuprofen in the person's system decreases by 29%. How much ibuprofen is left after 6 hours? Okay, that is another exponential decay or decay model, except we're not using the half-life because we're not losing half of it. We're only losing 29%, right? So we're going to start with A equals, okay, our principal, 400 milligrams, okay, and if ibuprofen decreases by 29%, so we have 100%, and if we decrease by 29%, we have 71% remaining, or we will have 0.71. Okay, and this happens see, each hour, right? So after every hour this happens. So we are so our in this case is going to be 1 because it happens after every hour. Okay, so it's going to be after 6 hours, so to the power of 6 divided by 1. But again, we don't really need the 1 because 6 divided by 1 is still 6, right? So in your calculator, you're just going to type in 400 parentheses 0.71 to the power of 6. And I'm doing all this at once. If you're on a home computer or you're on a Chromebook or on your phone, you may have to do a little bit at a time. Okay, the correct answer should be 51.24 milligram. You can use a couple more digits if you want, but I decided to stop after the 4 because there's a 0 behind it. So total is going to be 51.24, and we'll say that's milligrams. Right? That's number 8. Number 9, you deposit 1,600 into a bank account. Right? Find the balance after 3 years. Right? For each of the following situations. So I'm going to go ahead and So part A. Right? So total amount after 3 years. So we got 1,600. Right? And the formula goes, it's the principal times 1 plus the amount, which is 2.5%, translate to 0.025. Okay, do not use 2.5. If you use 2.5, that would mean 250%. Okay, so use 0.025 or 0.025. Right? And this is going to be compounded monthly. You look here, it says the deposit pays 2.4% annual interest compounded monthly, meaning 12 times a year. So divided by 12. And then if we're looking at this, it's going to be for 3 years, but for 3 years at 12 times a year, it's going to be a total of 36. So you may want to write 36 right here if you're going to be calculating it on a slower pace. But I'm going to go ahead and type it all in just so you can see how you can do this all in one fell swoop. So I'm going to go ahead and type in 1,600 parentheses 1 plus, and this one's a little complicated, so you can do it in small steps, but because I'm pretty good, not to be cocky or anything, but I'm pretty good, so I can do this all at once. So 1 plus 0.025 divided by 12, close that parentheses, to the power of, and then I'm going to go ahead and open the parentheses because I want that 12 times 3 to be together, and close that parentheses. You should get a total of let's see, 1,724, and that sounds about right. So equals $1 $1,724.48. Okay, and that's 2.5 annual interest rate compounded monthly or 12 times a year. Okay, do this next one in blue because it's kind of tight right here. So same scenario again. We got 1,600. Okay, 1 plus, but then this time around it's going to be 1.75%. Again, do not use 1.75. That would mean 175%. Okay, so 1.75% means 0.0175. That is the number, that is your interest rate. And this is compounded. If you look here, before my writing gets in, it says compounded quarterly. Okay, compounded quarterly means 4 times per year. So your N is 4, and this is T times N, which ends up being 4 times it by, and it's still going to be 3 years. All right, so all of these scenarios are all going to be 3 years. So it's going to end up being 4 times 3 or 12. Okay, so if you're working it kind of slowly, you can write down as 12. But again, I'm going to go ahead and type all that in, all in one fell swoop. Right, so 1,600 1 plus 0.0175 divided by 4. Close that parentheses, to the power of 4 times 3. Close that parentheses, which means you get, and you can see they're all going to be about the same price, the same amount, right? Roughly the same amount. This comes out to be 1,686. So you didn't really make much. 0.05 or 5 cents. Okay, so after 3 years, and think about it, 1.75% is not that much. Okay, it's not very much. So that's why after 3 years, you're only making $86.05. So okay, C. I'm gonna put this one in red. The account pays 4% annual interest compounded yearly. So this one, it's on that your in is going to be ones, right? One, which means once a year only. So A equals same scenario, 1600, 1 plus, and the 4% is going to be 0.04 compounded yearly. So I mean once a year, and once a year for 3 years. Okay. So this one's a little easier. And if you don't want to put the ones in there, you don't have to. But for me, I'm going to go ahead and leave it at 1600 parentheses 1 plus 0.04 divided by 1. And it's going to be the same thing. I probably shouldn't even have done that. To the power of, and again, 1 times 3. That's going to give me $1,799.78, right? So this compounded yearly should be less if it was at the same annual interest, or the same percent. But because it went up to 4%, right? This is the biggest thing that changes. We're getting a whole lot more money. Okay. Okay. Number 10. Let's see. You buy a new computer for $2,100. That's a pretty pricey computer. But hey, new gamers nowadays, you probably need something that expensive. Right? The computer decreases by 50% annually. So this, we can actually use the half-life formula for this, because if we lose, or if it decreases 50%, that means we still have 50%. So we can utilize that half-life formula for this. Okay. When will the computer have? Ooh, this one's interesting. When will the computer have the value of 600? Okay, so this one actually is going to be a little bit beyond your reach, or if you don't remember much from last year. Okay. So our equation for this one is going to be A, which is our final amount, equals principal, which is 2,100. Okay. And it's going to be half only, or it decreases by 50%, which means we keep 50%, right? And then we want to know, well, how long is that going to take? And it decreases by 50% annually, meaning once a year. So divided by 1, but again, that 1's not going to affect anything. So I'm just going to go ahead and just get rid of it, just for simplicity's sake. Okay. Now, it says, when will the computer have a value of 600? So this is actually telling us, hey, at the end, our A, our final amount, is going to be 600. So we are actually going to put 600 in here. All right, and now we just got to solve for T. So first, a couple things. We need to get rid of that 2,100 from the right-hand side. So I'm going to go ahead and divide both sides by 2,100. Okay, and when I say divide by 2,100, I mean the whole side gets divided by 2,100. Okay, but since it's multiplication, I can just divide out which part I want, which is this part right here. Okay, so 600 divided by 2,100, I can cross these two zeros out and cross these two zeros, and it'll just be 6 over 21, and if divide each one by 3, I will actually get 2 over 7. Okay, so I'm going to actually move this down a little bit. Okay, and I'm going to actually make a little space right here. So I need a little extra space. And I'll come back to that later. Okay, and maybe down here too. Okay, so my new equation is 2/7 equals 1/2 to the t power. Okay, and it looks like this. Okay, now you might have learned this last year, and we're actually going to learn this again. I'm not sure why I put this one on there. Maybe it's a challenge for some of you more challenging students, or students that like to be challenged. But how do we get rid of that 1/2? Well, to get rid of that 1/2, you actually have to do something called, you got to take the log base 1/2 of both sides. Right there. Okay. So that's what you have to do. So let me write this a little nicer for you. So 2 over 7 equals 1/2 to the t power. This really should come down to log base 1/2 of, and log base 1/2, both sides. And then this is going to be of 2/7. That's going to equal log base 1/2 of 1/2 to the t power. Okay. And from that, a log base 1/2 is going to inverse with a exponential 1/2. And that's going to just leave you with t. Okay. Now here we do have to worry about this side. So we have log base 1/2 of 2/7. Okay. And you cannot actually, or at least my calculator don't have that option. We have to do something called change of base. And again, we will learn a little bit more later on. But the change of base basically says you can use any base you want. And in this case, because my calculator only has base E and base 10, I'm going to use log base 10, or at least in my calculator, it's log, and then I'm going to go ahead and do 2/7 over log. And capital LOG just means log base 10, and then over 1/2. So you're basically utilizing a different base, a different log base to figure out this log base 1/2. And to do that, you're going to use the argument on top, and then you're going to use the log base, the 1/2, as the argument on the bottom. And that's going to give you our t value. So in my calculator, okay, watch what I'm doing. So I'm using that log base, the capital LOG, okay, and it's really just base 10, and it really doesn't matter which log base you use, okay. But so, oops, sorry, let me get rid of, I want to get rid of those circles. That is getting a little bit in the way. Okay, so in my calculator, onto the right hand side, I'm going to go log base 10 of 2/7 divided by log base 10. And I got to use the same log base of 1/2. Okay, that's going to give me 1.80735. Okay, if I decide to use the other log in the calculator, a log base E, which is the ln 2/7 divided by ln again, because if I use log base E, I have to stick with log base E of 1/2, and you will see that it gives me the same answer. Okay, so we know that t equals 1.807. So I'll just say 1.8 years. Okay, and you can sort of do this, not exactly the same, but you can sort of do this on the calculator. Okay, you think about this, right? You bought a computer for 2,100, and it decreases in value by 50%. So that means that you divide it by 2, right? So for after 1 year, it's worth 1,050, right? And if you divide it by 2 again, divided by 2, after 2 years, it'll be worth 525. But we don't want to see, but what we have is, it's asking when is it going to be worth $600, right? So after 2 years, it'll be worth 525, like how it is over here, right? So that's after 2 years. Okay. Well, after 2 years, it'll be 525. So that means that for it to be 600, it's going to be a little bit less than 2 years. So roughly 1.8. That seems really, really reasonable to me. Okay. All right. That's number 10. Okay, I'm going to delete all that. So if you need it, pause it while you're writing all that down. Okay, number 11. You drink a beverage of 120 milligrams of caffeine. Okay, each hour, the caffeine in your system decreases by 12%. Okay, how long until you have 10 milligrams of caffeine left in your body? Okay, again, same idea as the last one. We will have to set it up just the same. Okay, so we have, let's see, at the end, so they're asking about 10 milligrams, so we'll have 10 as the final amount, and we start off with 120 milligrams, right? And if we decrease by 12%, you could do that on the calculator. 100 decrease it by 12%, that's going to give you 88%. So it's going to be 0.88. Okay. And then this is going to be, and we don't know how many time, what the time is, and it's going to be each hour. So it's going to be divided by 1. And again, we don't really need that 1. So we'll just put a T. Okay. And now we just got to go through the process again and figure out what that T is. So like how we did before, we're going to divide both sides by 120 because we need to get the T or isolate the T. So 120s cancel and we get 10 over 120. And I'm going to go ahead and reduce that down to 1 over 12. is equal to 0, or sorry, 0.88 to a t power. And again, I need to get rid of that 0.88, so I'm going to go ahead and use log base 0.88. So I'm going to use log base 88, both side. Okay, so that's log base 88 of 112 is equal to log base 88 of 0.88 to a t power. And by doing that, I've managed to eliminate this, where you can say that the power of t comes to the front, and log base 88 of 88 is just 1, right? So either way you do it, you're going to end up with just t as your solution on the right-hand side. On the left, again, we're going to use a change of base, and I'm not going to go through the process again, but I'm just going to go ahead and use log base 10 or log, and I'm going to go 1 over 12. So it's the argument first, or the font big, right? The font size big number on top divided by log, and then the little subscript or the small font, the 0.88 on the bottom. Okay, and you should get 19.438. That's in hours. So 19.438. This is hours. Okay, so after almost 20 hours, you should have about 10 milligrams left of caffeine. And again, you can try it on the calculator, but this time you're going to have to multiply it by 0.88. So I'm not going to go through the process because this video is long enough already. Okay, so pause it if you need to copy this down, but I am going to delete all of this. Okay, last one. Foundation of your house has about 1,200 termites. Okay, that's not a lot, but that's enough to kill a wall or damage a beam. So that is quite a bit, but termites are so small that it's not even going to be that much, but it is enough to reproduce though. Okay. Let's see. So that's our initial amount, 1,200 termites. And it says the termites grow at a rate of about 2.4% per day. How long until the number of termites doubles? Okay, so this is sort of like the last one. It doubles, so that means it's going to be 2,400, right? Because that's double 1,200. And then that's going to be 1 plus, right? 2.4%, that's going to be 0.024. And it doubles, let's see, at a rate of 2.4 per day. So that's going to be once a day. So you can put a 1 here, and that'd be 1 here. And then we're talking about, how long does it take? So we're looking for the t. And again, if you want to kind of simplify things down, you don't have to worry about the ones. Okay. So, well, I guess I'll do that because I'm actually solving it this time around. So 0.024. Okay. So I'm going to go ahead and rewrite that. Okay. So I'm going to go ahead and try to solve this for the t, which is that little exponent. So divided by 1,200, divided by 1,200. Okay. And that's going to cancel out. 2,400 divided by 1,200 gives me 2 equals, and this is going to be 1.024. I've added those numbers inside together to a t power, and we're going to do exactly the same thing. We're going to go ahead and log base 1.024 both sides. So log base 1.024 and log base 1.024 both sides. So log base 1.024 of 2 is going to equal log base 1.024 of 1.024 to a t power, right? So all of that. And again, by doing that, we've managed to free our exponent of t. Unfortunately, on the right-hand side, we're going to have to figure it out using the change of base rule for the log, right? And again, our calculator doesn't have a log base 1.024, so we will have to change the base to log base 10 or log base e. Okay, I'm using log base 10, so I'm doing log base 10 of 2 divided by log base 10 of 1.024. Okay, and that's going to give me 29.22 days. Okay, so if you want, you can say approximately 30 days, but I mean 29.2 or 29.22 seems reasonable enough. All right, so that's your homework.